We're demonstrating our new 40 volt 50 amp H-bridge Arduino Shield. We have the shield connected to a 1 kilowatt e-bike motor. A second shield controls an electric brake to load the motor. We'll flip the enable switch and rev up the motor. Next, we'll change the direction. The unloaded current draw is about 5 amps. Last, we'll turn on the brake to load the motor. The motor draws significant current at maximum load, but we can use the enable switch to reliably shut off the power whenever needed. Here's the Arduino program we use for the motor control. You can download the basic program from our GitHub repository using the QR code. Here's the Arduino code we use for the brake. Here's the H-bridge Shield circuit. The heart of the H-bridge Arduino Shield is 4 power MOSFETs, 4 ultra-high CMTI isolated MOSFET drivers, and 2 ultra-miniature isolated DC to DC converters. The low-side IL610 CMTI isolators level shift the Arduino outputs to drive the low-side MOSFETs at 6 volts. The high-side isolators drive the high-side MOSFETs as the MOSFET source voltages float with the load. The 2 ILDC13-15E isolated DC to DC converters generate floating 6-volt supplies referenced to the MOSFET source pins in order to power the high-side isolated gate drivers. The isolators have extremely high common mode transient immunity, or CMTI, so they do not glitch even when the MOSFET source pin voltages change rapidly during fast MOSFET switching. The resistors in series with the isolator input coils set the input current to approximately 12 milliamps. The resistor values are selected to maximize the CMTI. The analog switches provide standard enable, direction, and PWM inputs for a simple Arduino interface. The fail-safe 10 kiloohm pull-down resistors ensure the load is disabled until the Arduino powers up and provides outputs. The enable line allows all 4 MOSFETs to be disabled, such as during a reversal, to prevent shoot-through. A linear dropout regulator on the control side provides a 3.3 volt supply to the DC-DC converters. And a linear dropout regulator on the output side provides 6 volts to power the low-side gate drivers. The regulator and MOSFET's ratings limit the line input supply to 40 volts DC maximum. When the direction input is low and the shield is enabled, the left high and right low MOSFETs are on, and current flows like this. When the direction input is high, current through the load is reversed. The LM317 circuit includes diodes for short circuit and reverse voltage protection. One diode prevents the regulator's output bypass capacitor from discharging through the regulator during an input short circuit. Diodes also prevent the capacitor on the regulator's adjust pin from discharging through the regulator during an output short circuit. Diodes also provide reverse power supply protection. Zener diodes protect the MOSFET gates from overvoltage. And ferrite beads mitigate EMI. As we've seen, the shield can be used for motor speed and direction control, as well as robotics and DC to AC inverters. These are the key specifications: 2 kilowatt load with an 8 to 40 volt supply voltage, 7 to 18.5 volt input supply, 2 kV RMS isolation, low on resistance, minus 40 to 85 degrees C operating temperature, and the shield comes in the standard Arduino form factor. Key specifications for ILDC1X isolated DC to DC converters include 3.3 volt input supply with 3 different output supply versions. Soft start to minimize power requirements. Up to 4 kV RMS isolation. The full -40 to 125 degrees C temperature range. And an ultra miniature 3 by 5.5 mm DFN package. Key specifications for IL600 series CMTI isolated FET drivers include ultra-high CMTI, 200 kV per microsecond guaranteed, an extended 3 to 6.6 volt power supply range, full 2.5 kilovolt isolation, a passive input side with no power supply required, and ultra-miniature MSOP 8 packages. Click, email, or call for more information, or to order these shields today.